Hello all. So in the last session we were talking about statistical learning, where we have started with explaining what is data, types of data and how data is represented. After that we have seen central tendency, right? So when we talk about central tendency gives us, when we talk about statistics, central tendency gives us the statistical analysis of the data. So today in this session I would like to talk about variability. When I talk about variability, both central tendency and variability are actually the key concepts in statistics that will help us understand the characteristics in the data set. Okay, so we have seen central tendency is represented in three ways: mean, median and mode, right? So today we'll be discussing about another characteristics to learn statistics of the data, which is variability. Okay, so variability usually refers to how spread out or dispersed the data points are available in the data. Okay, so when we talk about variability, it actually describes the extent to which these data points differ from each other and from the central tendency. Okay, so from the central tendency, how the data variables are dispersed. Okay, so the variability can be high, low or medium. The high variability indicates that the data points are spread out over a wide range of values. As you can see here, the data points are spread out over wide range of values, starting from here, that is including negative values to the most positive values. And the medium central tendency means the values are in mid range, whereas the low variability actually suggests that they are clustered closely around the central values. Okay, as you can see, the low variability gives the normal distribution. Okay, so basically understand that variability will actually gives us how the data points are spread in the data set. Okay, now when I talk about variability, okay, so the variability along with central tendency are most important for understanding the statistics. So there are few things that we have to understand when we talk about central tendency and variability. Okay, first thing is variance. Okay, the variance is nothing but the squared difference between each data point and the mean of the data set. As you can see here, variance actually is a quantitative measure of the dispersion or spread of set of values. So when you see, it is actually calculated by squared difference between each data point. Here xi represents each data point and mu is nothing but the mean of the data set and n is the total number of observation. Okay, so variance will give us clear understanding about how each point is deviated out of the n points from the mean value. Okay, so central tendency and variability together will give us about clear understanding about the spread of data. Okay, now along with variance we also have standard deviation. The square root of the variance is nothing but the standard deviation. It actually provides us the measure of variability in the same units as of original data. Okay, so if you want the original data units to be applied and get the result, we use standard deviation. Okay, and the formula for standard deviation is square root of the variance. Next, after this we have mean absolute deviation. Okay, this is the average absolute deviations of each point from the mean. Okay, so when we talk about variance, it is squared value of the summation values, whereas when you talk about mean absolute deviation, it is the absolute of each data point from the mean. Unlike variance where which squares the deviation, here mean absolute deviation will actually take the absolute of the value. Okay, so when do we use this mean absolute deviation? Mean absolute deviation is actually used when your data set has so many outliers, or when the data is skewed or which is normally not distributed, or when you have to measure the variability in depth, or when you want to compare the variability of multiple data sets together, when you are doing forecasting or when you are going for decision making scenarios, we'll be using mean absolute deviation. Okay, now let's discuss all these points with an example and understand the clear insights of what each and every terminology is used for. Okay, so I have taken a simple data set in a variable called ages. I have list of 6 values, as you can see. So when I talk about variance actually measures the average squared deviation of each point from the mean. Okay, so let's see how do we calculate that. First we have to calculate mean. So mean is nothing but the average of all these values, all the 6 values, and mean is turned out to be 29.33. And after we do that, we'll calculate the standard deviation of each value with respect to mean. That is 22 minus 29.33 whole square. This is the value. 25, second data point minus mean, third data point minus mean, fourth minus mean, fifth and sixth mean. Okay, so when I want to calculate the mean, I'll go with summation of all the square deviations, that is summation of all this by total number of samples, which is 58.38. Okay, now when I talk about standard deviation, I'm applying the same thing. Okay, standard deviation is nothing but square root of variance. Here the variance which I have got is 58.38, and here the standard deviation of 58.38, the square root of that is 7.63. Okay, now when I talk about mean absolute deviation, instead of squaring, I take the difference between each data point minus mean and the absolute value of that. And when I talk about mean absolute deviation, it is summation of all the absolute deviation divided by total number, which is around 5.67. So mean is around 29.33, variance is 58.38, standard deviation is around 7.63, and mean absolute deviation is around 5.61. Okay, now when you observe this particular thing, okay, so this is all about the data set of age of people, right? Age is starting from 22 to 45. So when we talk about each term here, when we talk about mean, variance, mean is nothing but average age. Okay, so when I consider this particular data set of 22 to 45, the average age is nothing but mean, which is around 29 years. Okay, and then variance will clearly tell us the deviation of each point from the mean. Okay, so variance and standard deviation will actually give a sense of how much the ages vary from the mean in a squared form. Okay, and when I talk about absolute deviation, it will give us the alternative measure of variability, which is focusing on absolute distances without squaring. Okay, this is basically used if you want to interpret the original data set values. Okay, so understanding these measures will actually help us in understanding and analyzing data distribution and assessing how the data points are spread in the data. Okay, so central tendency will give you one particular value representing the entire data set, and variability will give us a clear understanding of how the data is spread in the data. Okay, so when I talk about data set, we have different features, right? For example, when I talk about the salary of a person, depending upon the experience, the salary would be different, right? So we have different ranges of values, and depending upon the category of the employee also, the salary differs, right? So if you want to make a clear picture analysis of all this data, we require variability. What is the starting point, what is the end point, what is the midpoint? So central tendency and variability together will make us will give us clear understanding about the data and the statistics in the data. Thank you.